Okay, this is 11.3, and this is the final chapter in probability, and this is what we're all working towards being able to do. So in this particular question, we have two outcomes. We have rolling a six-sided dice and rolling a four-sided dice. So I'm going to put the four-sided dice here. And when we look at our table, we clearly see that how many different combinations are available if I roll a six-sided dice and roll a four-sided dice. There are 24 different combinations, okay? So we learned that if we took the outcomes, so there's one of the, or sorry, not one. There is 6 possible combinations for the six-sided dice. There is 4. So our total number of possible combinations is 24. We can do that either way, either using this method, which is the product of individual combinations, or use the table like this. However, if we look at the first question, what is the probability of the six-sided dice? I don't know why it says this one. So the six-sided dice being a 4 and the four-sided dice being a 4. So of all those combinations of the 24, only one of those is 4-4, correct? Only one of them. So using our table, we can say one chance out of 24, and we can change that to a percentage by doing either 1 divided by 24 and getting 0.0416 repeating, which is approximately 4.2%. But it says determine the following probabilities and verify your calculations using a second method. So my first method was looking at my sample space and putting a check mark in each of the boxes that had blue 4, red 4, or six-sided dice 4, four-sided dice 4, and there's only one of them. But what we're trying to extend this to is by using this method here. And remember, the bottom number represents how many different combinations, but the top number is our favorable outcome. Favorable outcome. So on the six-sided dice, with this first one, how many favorable outcomes were there for that six-sided dice to make what I'm looking for true? How many were there? It had to be a 4, right? So how many of those combinations were a 4 in that first dice? Was there 4 of them on the six-sided dice? How many of the choices on the six-sided dice were a 4? 1. So the favorable outcome on that six-sided dice was just 1 chance out of 6 to roll a 4. How many chances on the four-sided dice to roll a 4? Again, just 1. Now we have the multiplication of two fractions, which is a grade 8 outcome. What's my numerator going to be if I multiply that out? 1. What's my denominator? 24. I get the same answer, but rather than using the table, I can just create individual probabilities and multiply them together to get the favorable outcomes as well as the combinations, the possible outcomes. Let's look at the second one. The second one says, what's the probability of the number less than 4 and the red less than 4? So we'll put red here, just so we remember, red and blue. So blue less than 4, red less than 4. Let's put a red check mark this time in all the boxes. So red less than 4, blue less than 4. Are all those boxes the only ones that are blue less than 4, red less than 4? Correct? Right? So how many of those? Those are 9 out of 24. Agreed? So there's 9 chances out of 24 that you will roll a number on the blue dice less than 4 and a number on the red dice less than 4. 9 chances out of 24, which has a percentage. 9 divided by 24 is 0.375. And as a percentage, well, I won't put approximate, it's exactly 37.5%. Okay? But rather than use this table, excuse me, I'm dying here. Rather than use the table of values and put check marks into each of the parts that meet the needs of what I'm looking for, I could simply use this same method here and see if it works. So how many, if I took this six-sided dice, how many on that six-sided dice were numbers that were less than 4? 3 of them. Only 1, 2, and 3 were numbers less than 4, correct? So there's 3 of the 6 numbers. How many on the four-sided dice were there? There were 3 numbers less than 4 on that one. So there were 3 numbers out of 4. When I multiply those out, what would I get? I get that same 9 out of 24 possibility. Okay? So I get the same answer without using a table. Does that make sense? I see you guys are all very enthusiastic about it. The last one says, what's the probability? Hang on a second. Okay, so the last one says, what's the probability of blue equaling 4 and red being less than 4? So I'll take my eraser here and just dab, 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 dab. Oh, that's not good. Dab, 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 dab. 3. How many of these are blue less than 4? So this is their blue up here. So blue has to equal 4, but red has to be less than 4. Well, all of the reds are less than 4. So less than 4, less than 4, less than 4. Oh, sorry, this one's not less than 4. This is exactly 4. So out of all the 24 combinations, the only ones where blue is equal to 4 and red is less than 4 are these 3 right here. No other ones have blue equal to 4 and red less than 4. So we have 3 chances out of 24, which in lowest terms is 1 out of 8, which is 12.5% chance. Grade 8 connection. How many numbers were equal to 4 on a 6-sided dice? On a 6-sided dice, how many numbers were equal to 4 on that 6-sided dice? How many numbers on a 6-sided dice are equal to 4? Come on, guys, it's an easy question. Just one of them, just the 4. How many on the 4-sided dice were less than 4? 3 of them. When I multiply it out, I get this, and therefore I get that. Okay? Does everyone get that?